Yep, we're good to start. So my name is Maciej, or Maciek. It goes both ways in Polish. And I represent vlayer Labs. And let me start with quick intro, actually, because we often refer, when speaking about vlayer, we refer to TLS Notary and we refer to standing on the shoulders of giants. So the green timeline is the timeline of TLS Notary, which has started back in 2013 on Bitcoin forum, is in a way older than Ethereum. And here are we in 2024. vlayer was founded as a company to bring, with a mission to bring Web2 data on-chain. So what we started with was a more general approach to getting Web2 data on-chain, and then through reiterations, we ended up with using TLS Notary and zkTLS to do so. So a quick memory run. We first met TLS Notary in April 2024. That was in Amsterdam, a cool place, like a little workshop room. We spent the whole week hacking, talking about use cases. Few companies were built here actually. So Opacity, Hersh was there, Sahin, zkP2P. So yeah, that was a great place to be. Then we had the chance to invite Thomas with the presentation, with a talk, and Henrik with a talk to Warsaw, where we are headquartered. It's not only talks, we also produced some resources together with TLS Notary. So there's a vlayer playbook on web proofs, a verifiable data report available on our site, but also a white paper, and I think it's the only white paper format thing about TLS Notary, the only one available on archive. It gets cited from time to time. People are reading it. I think it's also cool that it somehow gets the hands of TLS Notary to the academics. My background was academic, so I really wanted to push for something like that. But it's not only like meetings, workshops, writing stuff is cool, but at the end of the day, it comes down to building. And what we believe we are building is the online trust, both on-chain and off-chain. And just to recap quickly, I know Thomas' presentation was very detailed on various modes of TLS Notary, but essentially, TLS Notary web proofs, zkTLS web proofs, can be generated in two modes. One with designated verifier, where verifier runs MPC protocol together with the client, and that's essentially a trustless mode, but the verifier has to be involved in the MPC computational process. Or with outsourced notary who signs the transcript, so the notary who participates in a TLS session signs the transcript, and then the transcript with the signature can be delivered to any third-party verifier, can be reused many times with different verifiers. And when talking about on-chain proving this stuff, bringing this stuff on-chain, we will be mainly focusing on this direction with a third-party notary. Yeah, because when web proofs or zkTLS meet the blockchain, this way is pretty much unfeasible because the blockchain has the computational limitations and cannot participate in this MPC action directly. I really hope one day it will be possible to do this directly on-chain and put the verifier on-chain and run the protocol without any additional trust issues, guarantees, security assumptions. But for now, the best we can do is use external verifier and use this signed transcript, signed attested transcript on-chain. So what we want to do, we want to ideally verify this signed attestation off-chain and somehow bring the information about the signed transcript that it's correct and it has correct data on-chain, so then it's publicly available and can be used in on-chain use cases. So for triggering your smart contracts in some way, let's say. So how to do that? That's a good question. And the question you need to ask yourself before doing that is, how much do you care about security? Because there are like at least 5 models of doing web proofs on-chain, of doing zkTLS on-chain, and each comes with their own security guarantees and security assumptions. So let's go through that. The first naive way is just trust notary. So if we trust notary, then we can simply get the signed attestation, deliver it to verifier. Verifier will verify the transcript, will verify the notary's fingerprint, will sign that it's all good, and put it on the blockchain. So that is a fully permissioned solution, because we as a blockchain verifier need to trust some off-chain entity, either notary or the verifier who is off-chain. So that doesn't really work until the permissioned solution is good enough for you. I'd say it might be good enough for some POCs or for some early stage projects where you can, for example, roll out your own notary, so you will be signing the data for your clients. Could be good enough, but for general model, for general use of web proofs on-chain, I don't believe it's a good idea to do that. So, because we essentially have the single point of failure, which is an off-chain entity, and we don't want to have that, like, at all. So what we proposed at vlayer almost 2 years ago is running off-chain verifier in zkProver. And this could be somehow confusing because we end up getting many provers and many verifiers, but let me break it up for you quickly. So we go with zkTLS protocol with a notary. We generate a signed attestation. And what we do then is we deliver the attestation to the verifier running in zkProver. And the verifier verifies the attestation, so we end up with a TLS transcript signed by notary and a zk proof that the proof was verified correctly. You cannot forge that. What you need to do for that is run the, for example, TLS notary verifier in zk, which is quite expensive computationally, to say at least, but it's doable. So zk has came a long way even in the last 2 years when we were exploring that direction. And I must say it's doable, and people are using this because it significantly reduces the trust assumptions that we have in the system. Because what we are building here is this kind of multi-sig 2 out of 2, because we have a notary, we have a verifier running in zk, and even though notary can collude with client, we need this like 2 signatures. So there is no chance that forged proof will be verified correctly because of TLS notary guarantees, and there is no chance that verifier will misbehave because it runs in zk, so if he misbehaves, we won't get a proof of correct verification. So I'd say, like, the only way to break this up is client colluding with a notary in a way that client steals the notary server and runs it on his own. So if we are able to identify the client and say, yeah, if you steal the notary server, we know who you are. Such scenario is pretty much very reasonable here. And how we do it at vlayer right now. So we start with generating a web proof with TLS notary protocol. And you can do it either server side, we've got API endpoint. For server side, you can notarize public data, you can notarize the data if you have OAuth. So anything you can do via normal API, you can do probably with vlayer. Or you can go the client-side route through a browser extension or native mobile applications. And that's what we call Vouch. So Vouch is an app built on top of vlayer protocol, which is essentially a data source catalog with browser extension and mobile apps, which can notarize all your private data across different data sources. So we have like hundreds of data sources right now ready for all your use cases: proof of address, proof of identity, proof of historical activity. And you can swiftly integrate this with the rest of the machinery, which is generating the zk proof with another API endpoint we call compressed web proof. So once you have a web proof obtained either server side or client side, you throw this web proof at our zk VM, you generate compressed web proof, and then you can verify the proof either off-chain with another endpoint or with Solidity smart contracts. For those, right now we're using the RISC-0 verifiers, which are deployed over several EVM-compatible chains, or you can roll out your own verifier, which will be compatible with simply verifying the Graph16 proof. That's something that we are getting extra here. It's this kind of standardization, that what we end up verifying on-chain is not some attestation with some weird cryptographic commitments to unpack, but we end up with a Graph16 proof to unpack on-chain. So 2 years ago, we implemented our own verifiers. Right now, the RISC-0 verifiers spread around in many chains are good for that. Okay, so that simplifies that. Here we are with vlayer and with web proofs and with proving Web2 data on-chain. Now, few ways of how to even improve that, how to make it more bulletproof. And one way is using hardware enclaves. So we can either run a notary in a trusted execution enclave and verifier in trusted execution enclave. This will not result in zk proof. That's a typo. This will result in a TE attestation, of course. And I believe that's a great setup to have, because we all know how TEs work. So the hardware security guarantees are quite hard these days. I believe that's a setup which also gives us this standardization, because TE attestations can be standardized like our standard, and then the things we verify on-chain have some standard format. And I believe that's the newest version of zkP2P protocol. I don't know if Sahin is already there, but he could surely confirm later. That's the way how zkP2P v3 works. So they spin out notaries in trusted execution environments, and then the verification before the proof reaches a smart contract, it happens in TE. So they have a unified format of the verified data. It of course brings some questions. What if TE gets hacked? Then we are, you know what? It's bad. But those attacks are pretty hard, and most of the attacks listed here on this slide are for SGX. Now we have TDX, which appears to be more secure. So I'd say if you compare the security guarantees to the attack possibilities, attack vectors, it's a great hardening of the protocol after all. So especially with TDX around, and especially given the fact that the proof of concepts has already proven that it's fully doable. Yeah. So another variant with TEs is spinning out the verifier in zk instead of TE. So we get this 2 out of 2 multisig, and we are running notaries in TEs and then verification in zk. We put the zk proof on chain. That's actually the roadmap for vlayer. So we have a grantee who develops the notary servers in TEs. So we should have this kind of setup for on-chain proving very, very soon. And what we believe it should be like the state of the art for on-chain proving using zkTLS. Then this section should be called a dream, because all of those previous systems involved one notary. And what if we could have 2 and the verifier in zk? And what if we could have 3 or 4 running at the same time the TLS session with the client? That would be magnificent. I mean, we would have like the chance of hacking multiple notaries running in multiple TEs, let's say. I think I have this schema, yeah, right there. So it will be almost 0. But unfortunately, running the protocol like TLS notary, so MPC TLS protocol with multiple notaries without timing out the session, or most importantly, the handshake, it seems impossible. I don't know if Shank from Primus disagrees, because I know these guys worked hard on making this as fast as possible. There was some effort from MPC magicians in Tasio to make it happen, but I believe their conclusion was as well that it might not be possible to do this on a standard machine, on, let's say, 16 gigabytes RAM MacBook, without timing out the TLS handshake, which is very, very time sensitive. And it's becoming even, like, I guess it will become even more timeout sensitive. But if we could have one day, yeah, that would be great. Because that's hardly imaginable to be breakable. And now, as we have some time left, I will show you some ways towards decentralization of such protocols, because everything we discussed right now is centralized in a way. We could spin out notary and verifier in different places. We could spin out verifier locally, but it will be centralized. There will be like single notary, or even in like scenario we run at vlayer, so we are running geo-distributed notaries, but we run them all. So how can we decentralize such system? One way of doing that was done specifically for Web 2, Web 3 markets, like zkP2P does. And I don't, so maybe short remark before we start, none of those proposals are live. So you could hear, you could process, and guess why they are not live anywhere. But these are like great proposals and great food for thought to think about decentralization of the protocols. So the first proposition is from zkP2P, not general purpose, but specifically for Web 2, Web 3 markets. And we called it optimistic notarization. So once we have incentivized counterparty and a notary network with trusted notary majority with some transaction value clarity and important assumption regarding all notaries networks, so data immutability. I will explain this in a moment. Then we can perform, in a way, optimistic notarization. So what would happen? We will have a network of notaries where a notary will be picked randomly. The proof will be generated. It will be pushed on chain, but the transaction will be insured by the stake of the notary who signed it. And then we will proceed to dispute settlement period. So in a period of time, a majority of notaries could vote if the transaction signed by notary B was right or wasn't right. And if it wasn't right, then the majority of notaries would need to prove that indeed this transaction was different. So that's why we need data immutability here, because if the data changes dynamically, different proofs at different time steps will give a different result. So that's fairly reasonable for the transactional data, because once transaction is made, the transaction amount is not changing anymore. So we can notarize it multiple times to get the same value. But other than that, in like general purpose way, this wouldn't work. So such approach with dispute settlement, optimistic notarization, and insuring the transactions will not work if the data will be changing. So another proposal was from Opacity Network. And what they proposed was to be able to identify the clients and the notaries joining the network by using their valuable Web2 account. So this might be Twitter account, this might be some other social media account, but to make notaries and clients identifiable. I already mentioned that when the user is known, the security assumptions are much better. So this combined with verifiable timestamping, again, trusted majority and obligatory TE usage by notaries, this creates like a better environment and general purpose environment for creating a notary network. And one other proposition was coming from Reclaim protocol, again, the centralized notary network, or how do they call it, proxy network. So on top of honest majority, they add up the network assumption of proxy TLS mode. That's what Thomas probably already mentioned. We need to assume that proxy connects directly to the server. But what I like very much about Reclaim proposition is how do they approach economic rationality, because in the notary network they propose to run a mixed quantile auction, which somehow turns the notary network into a market. I don't know, guys, if you know Boundless, but they, in a way, did that to zk proving, and they had this like a little white paper where everything could be turned into a market. So Reclaim was a little bit earlier with that proposition, and I think it's great. Like it should be adjusted at some point, but it's a great starting point to get some economic rationality among the network of notaries and how the notary could be chosen from the network. What we don't like in this proposal is, again, this data immutability, because we want to have a general purpose protocol, not the one that serves only data which doesn't change in time. So we want to have a network of notaries who could notarize the data which is time dependent, which is changing. So we wrapped this up some time ago. I think that like a big picture. Not much has changed here. We wrap this up in a blog post. You can find it at vlayer blog, where we listed what are the security assumptions. What we didn't say which model is the best because they are all different. And since it's been almost a year, and I think none of them are in production, I think there is still a room for adjustments to running this decentralized notaries scenario. There is still room for a protocol which will do that. I don't know who will be first, but surely that will be something big that's surely going to happen for on-chain proving. And to wrap this up, I have a clear message for all of you. So study web proofs, study zkTLS, learn, build, and play. Join us in the second room, play with the workshops. It's really great to see your private data being reusable, being verifiable, being brought on-chain or being brought to Web 2 places that it hasn't been before. I really believe, yeah, it's very exciting and it will transform Ethereum ecosystem eventually. But we are approaching the point here in late 2025 where the technology is ready for users to play, to build, to experiment. You no longer need to know all the infrastructure details. I wouldn't say zkTLS has become commodity. I believe we will discuss this a little later today. But I think the tech is ready. So you can just build what we call the online trust and either hop on to one of the use cases that are there or try building your new use case, your new market, finding your new way to use verifiable data. That's it from me. Thank you, guys.
Oh, hi. So I really like to talk. I'm very curious. So for web proofs, they often and not, they come in variable length, right? Because like JSON, the JSON payload response is typically variable length by nature. You deal with list and stuff. And I'm curious because like for ZK circuits, they're often like fixed size. And I'm curious like how your proof system deals with that.
So what we do in ZK, in zkVM, let's say RISC-0 that we are using, is that we verify the TLS notary proof, which consists of certificate chain, then all the inputs, and everything inside is encoded in a TLS notary way. So this can be either a hash commitment or some encoding commitment, and this is what we unwrap in ZK. So we got, with encoding commitment, we go bit by bit through the whole transcript. With hash commitment, it's fairly simpler because we have a full hash of a transcript or transcript like slashed along the way, but with couple hashes. So that's how we do that.
Oh, okay.
That's how we do that. I'm happy to show you like more. How does it look in zkVM in terms of cycles, like step by step? How does it break down the verification here?
Okay, and one more question. So let's say like I want to create a web proof of like an Instagram post. It's like, hey, like I want to get a web proof of somebody's photo. How long does it take? Do you know?
I'd say in browser extension, we have a rough estimation of 15 to 20 seconds per proof. The proving time depends on a network request size, not the response size. And the requests are usually quite small. Like I'd say 2 to 8 kilobytes is the spread here. So this 15 to 20 seconds on standard bandwidth, it's a reasonable estimation. On mobile, it's a bit lower actually. So you can get it even faster. I don't know precise benchmark for Instagram post, but for some Instagram stats, it works in like 15 seconds.
Just on simple like comments, we have something new about decentralized attesters using like combinations of T or something like that. So you can update that.
Okay. Happy to hear more. Thank you.
Thank you for the beautiful overview of the many different approaches towards the problem. I love it very much. You mentioned the like variant 2 having the notary in the TEE and the verifier in zk is kind of the immediate roadmap for vlayer right now. I'm curious, what are the like challenges that you are currently overcoming to, I guess, reach that version of well, TLS, yeah, zkTLS.
So there are a couple angles. So for the zk proving part, we were using a zk VM, which is not ideal in a sense because it would be preferable to do this on device. So on device proving is one thing, especially for mobile, I'd say. But that's a far on the roadmap. For the zk part, in zk VM it runs pretty swiftly. With ECDS precompile, it's like a couple million of cycles there. So it looks good on this side. On the TE side, we really wanted to implement TDX, not SGX. So the most of the POCs of running notary in TEs was about SGX. So that's quite challenging, but we have a dedicated team at Livy Labs who are our grantee, who are exploring the TDX space specifically, and they should be shipping this in like upcoming quarters. So that's how it looks like for us. We know it's fully doable. It's just a matter of engineering effort there. Thank you then.